Hi, my name is Roberta. Welcome to this journey through science. Today, we are going to dive into one of the most exciting topics ever: astronomy and space sciences, Part 1, from our course, Mind, Matter, and the Cosmos Scientific Possibilities. In this session, we'll explore how the universe began, what's out there in the stars, and how scientists use incredible tools and missions to uncover the mysteries of space. Let's get started. Introduction. This session will help us understand what the universe is made of, where it came from, and how we study it. We'll learn about stars, galaxies, black holes, and even possible careers in space science. This isn't just science for textbooks, it's about real discoveries and missions happening right now. By the end, you'll see how science and space are connected to your own life and future possibilities. Big Bang Theory and Cosmic Origins. The Big Bang was the event that started it all, about 13.8 billion years ago. Imagine everything in the universe exploding out from a tiny point. We know this happened because we see galaxies moving away and can detect leftover light from that early time. This helps scientists understand how the first atoms, stars, and galaxies formed. Expansion of the universe. Ever since the Big Bang, the universe has been growing. Galaxies aren't just staying in one place, they're moving apart from each other. This was discovered by Edwin Hubble, who noticed light from galaxies looked stretched, or redshifted. It means space itself is expanding, not just objects moving inside it. Formation of elements and cosmic microwave background. Right after the Big Bang, the first elements, hydrogen and helium, were created. Later, when the universe cooled, light could travel freely, leaving behind a glow called the cosmic microwave background. This light is still all around us and gives scientists clues about what the early universe looked like. Structure of the universe. The universe isn't just a random mess, it has structure. Stars group into galaxies, and galaxies form clusters and webs. These webs have big empty spaces called voids and areas packed with matter. This helps scientists study how gravity shaped the universe over time. Galaxies and galaxy clusters. Galaxies come in all shapes: spirals, like the Milky Way, round ellipticals, and irregular ones. Galaxies can group into clusters with thousands of other galaxies. Sometimes, galaxies crash into each other and merge, creating even bigger galaxies and starbursts. Stars, birth, life cycle, and death. Stars are born in clouds of gas and dust, called nebulae. Over time, gravity pulls the gas together to form a star. Depending on its size, a star may end its life quietly as a white dwarf, or explode as a supernova and become a black hole. Every star, even our sun, has a life cycle. Planetary systems and the solar system. Stars like our sun often have planets around them, forming what we call planetary systems. Our solar system has 8 planets, and many other objects like moons and comets. Earth is special because it's just the right distance from the sun to have liquid water. Moons, asteroids, and comets. Moons orbit planets. Some are icy, some rocky, and some might have oceans under their surface. Asteroids are space rocks, mostly between Mars and Jupiter. Comets come from far away and grow bright tails when they get close to the sun. Light and electromagnetic spectrum in astronomy. We learn about space by studying light. Light comes in many forms, not just the kind we see, but also radio waves, infrared, ultraviolet, and more. Each kind of light tells us something different about stars, planets, and galaxies. Tools of space observation. We use powerful tools to study space. Telescopes on Earth and in space help us see faraway galaxies. Some telescopes detect radio waves or X-rays. Satellites also help us look at Earth and space without interference from our atmosphere. Space probes and rovers. Probes like Voyager travel far from Earth to study planets and even leave the solar system. Rovers, like Perseverance, drive around Mars, studying rocks and soil. These robots help us explore places humans can't go yet. Dark matter. Dark matter is a kind of matter we can't see, but we know it's there because of how it affects gravity. Galaxies spin faster than they should, which means something invisible is helping hold them together. Scientists are still trying to figure out exactly what it is. Dark energy. Dark energy is even more mysterious. It's causing the universe to expand faster and faster. We don't know much about it yet, but it makes up most of the energy in the universe. Understanding it could change everything we know about physics. Black holes. Black holes are formed when giant stars collapse. Their gravity is so strong that not even light can escape. But scientists can still study them by looking at how they affect nearby stars and light. They're some of the most powerful objects in space. Milky Way and exoplanets. Our home galaxy, the Milky Way, is huge and full of stars. Around those stars are planets called exoplanets. Some might even have the right conditions for life. Scientists use special telescopes to find and study these planets. Space exploration missions. Missions like Apollo, Voyager, and James Webb help us explore space. Apollo took humans to the moon. Voyager is still sending back data from beyond our solar system. The James Webb Telescope shows us galaxies and stars that formed billions of years ago. International space agencies. Space exploration isn't done by one country. NASA, USA, ESA, Europe, and ISRO, India, all lead important missions. They build rockets, launch satellites, and share discoveries. It's a global team effort. Emerging technologies in space science. New technologies are making space science even more exciting. Reusable rockets make launches cheaper. Robots and AI help us study planets and analyze data. New telescopes are helping us look deeper into the universe than ever before. Careers in astronomy and space science. If you love space, there are many cool jobs you can do. Scientists, engineers, and teachers all help us learn more about the universe. You could build rockets, analyze star data, or even teach others about the stars. The sky isn't the limit. It's just the beginning.